Very good morning, one and all. It's probably a very rare occasion for a computational neuroscientist like me to be talking at a financial forum like this. And I thank you all for this incredible opportunity. So I was always intrigued how the brain works. With 10 billion connected neurons, it's able to process super exponential amounts of information. The information is visual, sensory, auditory. On top of this, the brain has creativity and emotions associated with it. As you can see, this is a recording of the neural activity from the brain in a happy state and unhappy state. That was me this morning when I started driving, but as traffic kept delaying me, I was slowly leaning to that. With 63% of the world population and their online presence, the amount of data that is being generated and the data being the text or videos is enormous. But do we have the right kind of compute today to process all the troves of this information? If you look at the general purpose computers of today that have the CPUs and the GPUs, which perform arithmetic logical operations and parallel processing, they have a form factor of around 4.3 pounds and they take around 45 watts of power. So you all heard about Watson. So when it won the game of Jeopardy, it consumed around 85 kilowatts of power just for that mere task. And when AlphaGo could beat the world champion in Go, in the game of Go, it consumed about 1 megawatt of power. And here I'm marveling how the brain, with just weighing just 3 pounds, is able to only consume 20 watts of power and yet process so much of information. Have we reached the ultimate limit of computing? Isn't this driving us and motivating us to build more energy efficient computing systems? And that has led to the evolution in the field of AI. Here's a quick riddle for all of you to make sure you're paying attention. And could anyone take a guess as to what this character could be? The clue is it's a numeric character, and I've broken down into segments. And this is just to show you how the brain also breaks down information in terms of features. And those features could be like circles or edges or contrast and hues. It puts them all together to process information. And this is one way of representing information in lower dimensions so that it becomes efficient to process this. And this has led to a lot of what is AI today. We have tools like the convolution neural nets, which are used for visual recognition and computer vision. And the recurrent neural networks are inspired from brain's own feedback mechanism to generate speech and for language understanding. And what you see on the far right is the generative adversarial networks that are being used today to generate a lot of artificial data. This is all to just showcase what is the art of possible and what we can do together to transform our businesses. So we are used to this traditional way of breaking down the business process into subtasks and handling and letting bots handle each of these subtasks to perform these functions. But as you can imagine, once you stitch these subtasks together, it only becomes cumbersome and unmanageable. And it also becomes complicated over time and expensive. And here comes with the advent of all the tools that we have with AI, you can now reimagine the entire business process from end to end, where AI takes a one-shot learning to performing a multiple of these subtasks together. And this sets the pretext to what I'm going to show you as a demo and like two examples from the fintech industry. The first we picked from banking, the logbox process. And second, I'm going to show an example from the insurance industry on how we are transforming these with AI. So what you're going to see next is the logbox process coming up. And logbox is the bank's way of streamlining check deposit process. So a lot of checks come in, millions of checks, and it's a very laborious and manual process. Where you have to reconcile the information from checks, stubs, and invoices, and you have to cross-verify this information. And this is complex. This is complex because the checks have handwriting in it. It has a lot of these logos. It has a lot of these characters. So that's the complexities involved in using these checks. And post-pandemic, and this being a very essential process, businesses have to rethink on how this could be done. So here comes AI, where we use an ensemble of technologies of computer vision, natural language understanding, and character recognition, all fused in together to be able to extract macroscopic and microscopic features from checks. With this, you're reducing the processing time to much less time than what it would take manually, and also building a lot of operational resiliency in processing these. The next demo I'm going to show is a snapshot of how a lot of customer requests come to the insurance industry, and these are in huge numbers. And again, this is something that cannot be scaled manually. And these requests come in multiple forms. It could be voice requests, it could come through emails, or it could come through other structural forms. Here's an example I'm going to show.
Hi, Stephanie. This is Sophia calling from Axe Capital. Please change the business location for B724147 to Colony Place, Plymouth, Massachusetts, 23602.
Your request for address change is under process. Thank you.
This is an example of an email request coming in, and this is all unstructured data. And from unstructured data, the natural language understanding, the ability of the AI engine is able to extract key features and key entities and present it to the agent for processing. Here, you're also trying to retain your customer by quickly sending them automated responses, because a frustrated customer is always loss of business. So we want to mitigate such risks. And here is how AI also picks up key information from forms, agnostic to any layouts or any forms that keep changing year on year. We're able to do all this with an ensemble of AI technologies. And you can see the value realization that comes through and the scalability that we can achieve. Here, for an example, I only talked about Logbox and the request management automation, but we have a lot more use cases, and we're happy to talk to you downstairs and demo some of these applications. At the center of all of this is obviously a customer that drives our business and our thinking. But we also need to think about how we internally innovate, and we build algorithms but also we need the right kind of hardware to run these algorithms. So today we see the evolution of neural processing units and tensor processing units, because for great AI, you need good hardware. So we collaborate to enable this, and also what drives us is really the co-innovation with our customers. But have we reached the limits yet, or we need to test more? So here, where do we go from here? There's a lot more to be done, and it goes back to my first question of how we can build energy efficient compute systems. There's so much more to be done in the evolution of algorithms, evolution of hardware, but also new forms of computing like neuromorphic computing, where we are trying to mimic the brain's way of computing. So this is all leading us to think first principles and how can we push the boundaries of AI and all the possibilities that we can achieve. Thank you.